Welcome back, kids. I hope everybody is staying safe at homes. In the last lecture, we have seen the different techniques for measurement of high currents. We have seen the Hall generators for measurement of high DC currents, current transformers with electro-optical fibers for measurement of high power frequency AC currents. We have come across magnetic measurements like Rogowski's coil, magnetic links, resistive shunts for the measurement of impulse currents. So that will end unit number 3. So moving on to unit number 4, which deals with testing of high voltage equipment. High voltage equipment includes the insulators used in the transmission lines and other applications, bushings of the transformer, the transformers also, the circuit breakers, the isolators, the surge diverters, and the cables. So all these equipment are part of high voltage engineering. So before installing or using these equipments in practice in outdoor applications, we need to test these equipment in our laboratories, that whether these are meeting the standards or not. So our last unit deals with the different tests which are conducted on each of these equipment. And before moving on to the last unit, I thought it would be better that you become familiar with few terms which are related to testing of high voltage equipment. This current video provides an insight into the different terms which are widely used in our unit 4 of the course high voltage engineering. Let's start. The testing. So the tests which are conducted on high voltage engineering, they will be of two types broadly. One is a type test, the other one is a routine test. So if you bring up a new design, then a sample item of that new design will be tested to check for the quality and also the design features. So the tests which are conducted to check the design features or the quality of the design, those are called as type tests, and they are exclusively done on samples, not all items of the design. So if you carefully see the type tests, they are intended to prove or check the design features and the quality, and they are done on samples when new designs are introduced. But whereas on the other hand, routine tests are those tests which are to be conducted on each and every item before it is to be brought into service. So these are intended to check the quality of each and every individual test piece. These are done primarily to ensure the reliability of the individual test objects. So broadly speaking, two types of tests, type test and routine test. Type test, when you bring in a new design to check the design and quality, type tests are conducted, whereas routine tests are conducted on each and every test item before it is being brought into service. And next, we will move on to few terms which we usually encounter when we are doing this testing on high voltage equipment. As we have been stating in our first unit of high voltage engineering, that it's not just the conductor which carries the current. The other part is the insulator, which maintains a potential. That is more important in electrical engineering. We do have different types of insulating materials. So all these materials are supposed to withstand certain amount of voltage based upon their properties. So while withstanding these voltages or their rated voltages, when there is an excessive or an increase in the applied voltage than the rated value, then these devices may experience flashover and there may be a damage to their insulating properties. So we will now come across the different definitions of the voltages which are generally used in the testing of high voltage equipment. The first one being the disruptive discharge voltage, which is defined as the voltage which is responsible for the loss of dielectric strength of an insulator. So if you go on increase the voltage on a insulating material, at some point the dielectric material or the insulating material loses its dielectric properties. That particular voltage is called as disruptive discharge voltage. So at this particular point of voltage, the material loses its insulating properties. So the voltage will not withstand and a current will be allowed to pass through the insulator. Since we have come across different types of dielectric materials, if it is a solid dielectric material, it will be a permanent loss of strength. In case of liquids, there may be liquids and gases, we may expect a partial restoration of the voltages and the strengths. But in solids, once you have applied this disruptive discharge voltage means the material has been collapsed. So coming to the disruptive discharge voltage, which means that this voltage is allowing a discharge, which means it is allowing a current to pass through your insulating material, which is highly objectionable. So this type of discharges which take place between two electrodes in a gas or in air or in a liquid material, it is called as flashover. If it happens in a solid, it is called as puncture. So two different terms. One is a flashover, which is basically visible, so which is generally observed in liquid and gaseous dielectrics. The other one is a puncture, which is commonly observed in solid dielectric materials. The next one is a withstand voltage. We do have different standards for the voltages in the high voltage equipment. So withstand voltage is the voltage which is to be applied to the test object while undergoing the withstand tests, which means that this voltage is to be withstand by your equipment for that certain amount of duration. Then only it is supposed to pass that particular test. So during the withstand test, this amount of voltage, when it is applied to your test specimen, your specimen must not experience any change in its properties. So that is withstand voltage. And next is flashover voltage. The voltage which creates a flashover in your material is called as flashover voltage. If the voltage is creating flashover every time when it is applied, it is called as 100% flashover voltage. Let us suppose it is creating only 50% of the flashovers, which means the probability of getting a flashover is just only 50% when you apply this voltage. It is called as 50% flashover voltage. If the probability is 20%, it is called as 20% flashover voltage. So like this, the flashover voltage will be there for each and every of the equipment, high voltage equipment, just like the withstand voltage. So these flashover voltage basically will be higher than the withstand voltage. And next is creepage distance. This is one of the important terms which you find in electrical engineering. Creepage distance is the shortest distance on the contour of the external surface of the insulator units between two metal fittings of the insulator. See here. Now, this is the insulator, commonly found composite insulator, which you use in practice in the recent past. See, these are the metal fittings, and this is the entire insulating material. See, this contour, entire surface, this is called as creepage distance, or what you call it as a leakage distance. You always wonder why these designs are being of this fashion instead of using a long straight rod. With this, because this improves the creepage distance. This is one of the most important factors which affects the breakdown potential. So you can see in the next picture very clearly. Let us suppose this is a metal fitting. The shortest distance is called as clearance distance. See, this is the shortest distance. This is assuming that this is the insulation support here. See, this is the shortest distance. It is called as clearance distance. But whereas if you take on the surface, if you consider only the surface, then it is called as creepage distance. See the blue line here, it is called as creepage distance. Now see here, there is a gap here. Now the shortest distance is always called as a clearance distance between the conductors. Whereas if you consider the entire path, it is considered to be the creepage distance. So creepage distance refers to the path on the insulator surface between the metal fittings. And next is the AC test voltages. AC test voltages are also specified in IS, and they must have an approximate frequency between 40 to 60 Hertz, and they must be very approximately sinusoidal. We do have our own tolerances. Mostly the deviation or the THD, maximum THD, must not exceed beyond 7%. So this deviation will be checked at regular intervals. And the other one is impulse voltages. As you all know, impulse voltages are basically characterized by, see, this is the peak value, this is the peak value, this is the rise time, and this is the tail time. Rise time, tail time. As you know, we have discussed these things already. Rise time and tail time. The definition of the rise time and the definition of the tail time. You can go through here. And all these tests are supposed to be done at certain atmospheric conditions. As you all know, according to the Indian standard specifications, there are certain standard atmospheric conditions, what we call it a standard temperature and pressure, STP. The temperature is 27 degrees centigrade, whereas the pressure is 1 bar, which is nothing but 760 torr. The absolute humidity at 17 gram per meter cube. So all the tests are supposed to be conducted on STP unless stated otherwise. So that's all regarding the introduction to high voltage testing. I hope you have gone through all these terms, and when we come across these terms, I hope you will be familiar with these terms. Thank you.